Everyone, Radical Tutor here explaining. In this video, we are going to look at how to integrate this question. This is an integral of e to power ax or exponential ax cos bx dx. So how can you integrate this question? Alright, so this question is coming from foundation calculus. Those that do foundation calculus or calculus 1, they are the people that do such type of integration. Alright, so now from here what we're going to do is that for you to integrate this function, you need to use a method that we call as integration by parts. So integration by parts is the method that we are going to use in order for us to integrate this question. Now, it must interest you to note that integration by part or by parts is given by the formula uv minus the integral of v du. So this is the formula that we use when integrating by parts. Now, when we look at this question, we can say that this can be our u and this can be our dv. So that's what we do when integrating by parts. So we are going to start by saying let u to be equal to e to power ax and dv to be the other function which is given, which is a cos bx. So we are saying that this is our u and that is our b. This is our u and that is our dv, just like we've written them there. Okay, so from there we need to make sure that from the u we get du and from the dv we get v. So getting du from the du is simply to just differentiate what is on top. So differentiating what is on top there, you get an a and you multiply that a throughout by the function. Okay, so that means we are going to get a e to power ax if you are to differentiate the e to power ax. Okay, so now from there we get v from dv. Now how do you get v from dv? So to get v from dv is simply to integrate the dv. So we are going to integrate this function in order for us to get v from the dv here. So by doing so, what we are going to do then is to integrate here. So integrating, what you do is you only differentiate the function here, which is the bx, of which you are going to get a b, but when integrating it comes as 1 over b. And then you need to integrate the cos. The cos, integrating a cos is a positive sign of that angle, which is the bx. So having gotten those assumptions, we can then put them or replace them in the formula. So the formula that we've already stated is here, which is uv minus the integral of v du. So that's what we are simply doing. Alright, so by replacing in that formula, we are saying that we have uv minus the integral of v du. So what we can do there is to replace what is our u. Our u in this case is this one, our v in this case is this one, v also is that, and then du we are putting this. So let's quickly do that and see how we can unfold with the question. So by doing so, we have our u, which is e to power ax. Our v, we are putting this, which is 1 over b sine of bx, and then minus the integral of v, which is 1 over b sine of bx, like that. Then from here we can multiply. We are going to multiply this part here. Also we multiply that part. So now don't forget that I've only replaced don't forget that, let me remove this. So don't forget that I've replaced on the v here. So this is our v, which is here, and then we need to also multiply this with du. What is our du? Our du is this one, which is a e to power ax. So we need to put it here, which is a e to power ax, like that. Okay, then after that, that's when you can now multiply. So you can simplify your answer by saying we have this times this times that. So by doing so, we are going to have e to power ax times sine bx. We are going to have e to power x sine bx, and then the 1 over b is a constant, to come outside. Then we remain with e to power ax sine bx. Minus, we have this minus here, so this is the minus that we have, and then we multiply 1 over b times the a there, because these two are constants, so you can multiply them. So we have 1 over b times a. You are going to have a over b, and then the integral remains of e to power ax or exponential ax sine bx. So this is what we have. So what I've simply done here is to multiply So what I've simply done there is to multiply. So I've multiplied. So what I've done there is I've multiplied the 1 over b times the a. I've got an a over b here, this one here, and then we've also multiplied e to power ax, which has just come in front, and then sine bx, which is there. So this is here and then this is here. That's what I've done. And then from here, what we're going to do is very simple, is just to now integrate this one further. So we need to integrate this one, this part here, in order for us to get our final answer. So we're going to keep this one and then integrate this part here. That's what we're going to do. So by doing so, what we're going to do is we'll say this is 1 over b e to power ax sine bx minus a over b. Now what we are going to do is that we are going to integrate again this part which is here. Now integrating this part here, we are again going to use integration by parts, because it is also having two functions multiplying, and therefore the only method that can be used here is integration by parts. So let's use integration by parts here to integrate this function, but bearing in your mind that you still have this function that we've kept in front here, so we shall use it later. I'll remind you. All right, so from here we are going to use integration by parts, where we're going to say let u to be equal to e to power ax and the dv to be equal to sine bx. So that's what we are going to have. And then from the u, get du. So from the u, when you get du, you are going to have a e to power ax. And then from the dv, if we are to get v, meaning that we are integrating the dv, so integrating sine bx is going to be 1 over b, because you only need to differentiate this one, so it's going to be 1 over b. Then you integrate a sine, you get a negative cos of bx, like that. So that's what we have. Then you replace that in the equation, or in the formula for integration by parts, which is uv minus the integral of v du. Okay, so that's what we are going to do. So by doing so, we are going to replace our u, which is e to power ax, and our v, which is negative 1 over b cos bx, then minus the integral of v. Our v in this case is negative 1 over b cos bx, and then our du is, where is our du? Du is a e to power ax. So we multiply there a e to power ax, like that. So from there, let's simplify. So we are going to get now our answer. Remember, don't forget that we have this answer that we kept. There is also a minus here and the 1 over b that we kept as well. So the 1 over b is kept, this one also is kept, and then now we are just getting the answer for this one, so that we multiply this answer with the 1 over b, which happens to be a constant. So by doing so, what we are going to do then is to simplify the answer that we've gotten here. So let's do that. So we're going to say this is equal to, we have e to power ax times negative 1 over b. We are going to have negative 1 over b e to power ax. Okay, then cos bx. What I've simply done here is to have multiplied these two, and then minus. So minus here, we are going to say also that negative and negative will give us a positive, so we're going to get a positive. Then integral of, we have this a times that 1 over b, we get negative a over b. Of course the negative was already given as a positive, so we're going to get a over b there as a positive, so we get a over b, and then we have the e to power ax cos bx, which is simply here. Okay, then from there it means that we've gotten the answer for the integral of this part here. So what do we do now? We need to multiply this answer that we've gotten for this, which is this, with the a over b. So let's do that. So by doing so, we are going to have I'm going to start by writing this so that I add to this answer, which is this other side here. So that's what we are doing. So I'm writing this and then minus this times the answer that we've gotten, which is here. All right, so by doing so, we are going to have the 1 over b e to power ax sine bx minus the a over b, which is this one here, times this answer that we've gotten for integrating this part. Integrating this part, we multiply it with the a over b. So by doing so, we are going to have the negative 1 over b e to power ax cos bx plus the integral of a over b e to power ax cos bx, like that. All right, so cos bx. Let me just write this again so that you're able to see. So we have the integral of, so the integral of a over b e to power ax cos bx. Okay, now we need to multiply the negative a over b times whatever that is inside there. So we have 1 over b e to power ax sine bx minus, we multiply negative a over b times negative 1 over b. We are going to get a positive a over b squared e to power ax cos bx. And then we multiply negative a over b times positive positive there, we are going to get, so we are multiplying this one with this. I've also multiplied this and that, so here we are going to get a negative. So by doing so, we are going to have minus a over b times this a over b, because these are all constants and therefore they can multiply. So it's very, very precedent for you to note that whenever you are integrating something and you have a constant, you need to factor out that constant, and factoring out the a over b, it means that it can multiply with the fellow constant a over b. So by doing so, we are going to have the a squared over the b squared, and then we have the e to power ax cos bx. So we write e to power ax cos bx. So that's that we've gotten. Now what we are going to do here is that don't forget that we have an integral here. So we have an integral here, we have an integral symbol, and the integral that we have is for this one here. Don't forget that there is an integral here for this part, so we are going to put an integral this side there. Okay, so that's what we are going to do. So you put an integral here like that. All right, now from there what you're going to do is you say that, remember what are we getting? What we are getting is, we want to see that the integral of this, we want to evaluate the integral of this. So that's the answer that we want to get for. All right, so now from here what we're going to do is we say we are getting the integral. So you say you are getting the integral of e to power ax cos bx, which is actually equal to, we've gotten that this is equal to, what answer have we gotten? We've gotten this answer here. So you say is equal to 1 over b e to power ax sine bx, and then plus a over b squared e to power ax cos bx, and then minus this a squared over b squared, and then we have the integral. So we have the integral of e to power ax cos bx. So that's what we have. Now from here what we're going to do is to correct like terms. So we're going to correct like terms and see how we can solve this. So you've seen that we have e to power ax cos bx is the same as e to power ax cos bx. That means we can correct this, bring it this other side as like terms, so we can do that. So by doing so, we are going to have the integral of e to power ax cos bx minus, so this is a negative, this side it is a negative, so if it is to come, or rather cross the equal sign, though my professor used to say something can't cross because it has no energy. Anyway, we can bring this one this other side, so we can bring this one the other side here, and then from there we are going to say, since it is having a negative, it can actually be transformed to a positive. So by doing so, we are going to have a plus a squared over b squared, which happens to be the constant, and then the integral of e to power ax cos bx. So those two are like terms. So this one and that one are like terms, and therefore we are only going to remain with this part here, which we have. So let's write this part and see what we have. So we have 1 over b e to power ax sine bx. Don't forget the part that I'm writing this part here. So I'm writing this part from there to there. This is what I'm writing. So sine bx, then plus, so you write plus there, plus what? A over b squared. So we have a over b squared e to power ax cos bx. That's what we have. Now here mathematically what we are going to do is we know that this and this are like terms, and we have the coefficient here as 1. Here the coefficient is a squared over b squared. So mathematically what we do there is, if in simple terms or in elementary mathematics, if we have 2x plus 4x, what do? We keep the x the way it is and only add the coefficients, which is going to be a 6, like that. So even here, since we have this one and this one are just the same, under the same integral, what we are going to simply do is to just add the what? The coefficient. So here the coefficient is 1, here the coefficient is a squared over b squared. So that's what we're going to do. All right, so by doing so, we are going to add the 1 here, which is the one which is this side, and the one, not there but here. So here we have a 1 plus the a squared over b squared. So we say 1 plus a squared over b squared. So adding this one, we can say over 1. Common denominator there is b squared. This into that is b squared. B squared times 1 is b squared plus a squared. So this is what we are going to have. All right, so we have a squared plus b squared over b squared. That's what we have there. All right, so let me write for you first. So we are going to say we have our a squared plus b squared over b squared. That's what we are going to get if you are to add this and that. All right, so by so doing, we now keep our integral, which is the integral of e to power ax cos bx. So we are going to keep the integral of e to power ax cos bx, and we say this, remember this is the x, and is equal to now what is this other side here. So what is in that other side, we can write it as well to be 1 over b. I'm writing it from there to there, so we have 1 over b e to power ax sine bx, then plus we have also the 1 over b squared, so which is 1 over b squared e to power ax cos bx, so cos bx, like that. Now remember, don't forget that what we are getting is we want to get the integral of e to power ax cos bx. That's what was given in the question. So this is what was given in the question, and that's what we are getting. Now how can we get it? So for us to get it, we need to make sure to remove this constant here, so that we just remain with what was asked to be gotten. So what can we do for us to remove this? We are simply going to divide throughout by this by that constant. So dividing throughout by that constant, we are going to say we divide this side by, so we are going to divide this side by a squared plus b squared over, or in simple mathematics we can say, instead of dividing, you can just multiply throughout by the reciprocal of this. So you can multiply throughout by the reciprocal of that. So by doing so, you can say you do this, you also do that, and you multiply throughout by the b squared over a squared plus b squared. So you're multiplying this expression throughout by the reciprocal of this, so that they cancel out. So here, meaning that we're going to have the b and the b squared will go. So the b and the b squared will go. The a squared plus bx and the a squared plus bx also will go. You remain with this part here. So you're going to remain with this part, which we can write as, the integral of e to power ax cos bx dx is equal to, we also multiply, remember we are multiplying this throughout, so we multiplied it to here, now we multiply it to there. So if you multiply it to here, you have 1 over b times b squared over a squared plus b squared, meaning that one of the b's, okay, this b and 1b which is on top there will go, meaning we remain with 1b on top over a squared plus b squared. Then e to power ax sine bx plus, we also do the same. So we are going to do the same to this part here and this part. So as you can see here, you have the b squared, and the b squared on top there will go, and you are going to remain with only a 1 on top over a squared plus b squared. So we are going to have plus 1. So we are going to say plus, we have a plus here, so say plus 1 over a squared plus b squared, and this which is e to power ax cos bx, e to power ax cos bx. All right, So that means that our final answer, if we are to integrate this, is this one here. Alright, thank you so much. See you in the next video. This is the Radical Tutor. Don't forget to follow my YouTube channel, also my Facebook page for more tutorials.